So today I'm going to talk about RAG, tricks from the trenches. It's about practical lessons from building retrieval systems in Python. Now, before I get to the juicy part, I have to do the mandatory introductory slide. Ciao tutti, sono Duarte. I'm Duarte. I'm originally from Portugal, but I'm based in Copenhagen, Denmark. I'm a machine learning / software / AI engineering contractor with over 7 years of experience. In the past, I worked in things like strategy, product management, management consulting, Big Four, things like that. Now I mainly help companies solve hard problems with machine learning and software. And in the future, there's a long-running joke about Italians in this conference, but I'm completely in love with a city called Ancona, which is a couple of hours down here, 2 hours down with the Frecciarossa in the Le Marche region. So I'm still convincing my wife in eventually living there. She's not convinced yet, but I'm working on it very, very hard, I promise you. I also have a blog and a newsletter. You might like it down on my website below. You might enjoy it, you might not, but I have fun writing it a lot. So if you're keen, join. Cool, let's get to the serious stuff. Before we get to the serious stuff, there's a long-running theme of me being a big fan of Italy. I am. This is my third PyCon Italy. There's two common themes here, alcoholic beverages and pizza. I have to say that I'm a big fan of both, but I'm also a big fan of the Adriatic coast. So if you have the opportunity to get lost towards the south here, towards the side of Croatia and the Adriatic coast, I really advise you to do so because it's one of the best places in the world, and that's where I spend at least a couple of months a year every year. So I definitely advise you to go there. All right, now we can go to the serious stuff. So today, we'll talk about RAG. My goal is to give you like simple, but yet practical advice of stuff you should do. I don't want to get too theoretical. I don't want to get too over the top. I just want to give you simple and practical advice. We'll talk about a couple of things. We'll talk about what's RAG, why your embedding choice sucks, why structured outputs matter. We'll talk about exploiting contexts and summaries. We'll talk about your beautifully ugly production data. We'll talk about, in fact, if your system is actually any good. And then I'll give you some final thoughts and resources for going beyond. Cool. What's RAG? I'm sure you heard about it on LinkedIn. Here's me running Olama locally, asking Quen 30B, where is PyCon Italia this year? Asking it to no think, because I don't want to wait 15 minutes for it to do its long thinking process. And it tells me as of now, PyCon Italia is typically held in Rome, but the exact venue and date can vary each year. Well, I mean, I'm not sure Rome is the right place. I actually been to Florence in the last ones, and now we're in Bologna, so Rome might not be exactly the correct answer. So RAG is all about this. RAG is all about providing the right context to your large language model. That's all it is. And this is a tweet from Hamo Hussein, a person I really like in the community, which is really, really true. It's just about providing the relevant information to your LLM. Now, you might also seen this implementation of RAG, which is I take an external document, chunk it up into paragraphs, embed them all and put it on a vector database, take my query, embed that, do a top K of the most similar embeddings to the response, and then I put that in an LLM and call that the response synthesis. That's RAG. Now, one of the things that annoy me about this graph, even though I'm a big fan of Sebastian Rachka and his book, Machine Learning Q&AI, is the fact that RAG doesn't mean VectorDB at all. In fact, we can use one of my all-time favorite libraries of Python called sentence transformers. I can take a model, dump it on the MPS device on my Mac, take a corpus of text, and then just query the corpus, embed the queries, and just use util.semantic search, and bam. The most similar to deploying Python with containers is how I deploy Python apps with Docker. Score is 0.85. So no vector databases. If someone tries to shove a vector database onto your company, making sure that you have to use a vector database from the 25 different vector database companies out there, rest assured, you do not. I could just pickle file this into my local machine and try to embed it like that. That's the way to go. Now, we see that RAG doesn't really mean vector databases, but in fact, RAG has become extremely simple. For example, there's another library I'm a big fan of called LanceDB. And with LanceDB, I can get a full-fledged working RAG system in about 25 lines of code. I take my model, then I define this Lance model, which allows me to define the text, which is the source field that will be embedded. It allows me to define the vector, which is the vector field. If the table doesn't exist, I create the table, open that table. The query is where was I born? and then I just do a table.search, allows me to do the whole embedding dance really quickly, and then I have my prompt, you're a helpful assistant, here's the text, the context, here's the question, here's my rack system, in 25 lines of code. Now, it has become really simple, but the premise of this talk is, has it actually become that simple? Because really, like, why did you choose those embeddings? Are users actually ever going to trust your responses? What if the user asks for a summary of your 10 gigabyte table? Is your production data really that clean with all of these nice questions and like full stops and punctuation and whatnot? Because when I Google, for example, it's dirty. It's really dirty. Like, I just write the minimum words possible. And how do we know our system is actually any good? We have no clue if we just do a 25-line rack system. That's it. You're just putting something into oblivion. OK, let's get started. First of all, your embedding choice sucks. Big time. This comes from a trauma of people telling me that embeddings don't matter. Let's consider a super simple example. OK? Let's just look at a sentence. The user query is, can weight affect asthma? It's a pretty simple question. Now, my corpus of documents is a set of 32,000 texts. They have an ID. These are the texts or the chunks or the paragraphs. And these are the title of the scientific paper from which they were extracted. 32,000 passages. Now, let's say I just build an initial RAG system. I take the user query. In the corpus, I put my 32,000 texts, get my model, sentence transformer, do the whole dance, top K, give me the top 10, that's it. I retrieve the most similar 10. But now for each one of these results, I'll check, is the answer, it's the context actually relevant? I ask an LM, hey, is this piece of paragraph actually relevant to the question? And we score about a 16.54, which effectively means that almost 75% of every chunk you give to the context is effectively useless. And now let's change just a single line of Python code. The only thing that changed in this slide is the name of my model. Instead of using all mini, I'm using NVIDIA NV embed v1. And now my score is 62.89%. That's about a 300% increase in your retrieval score. All I needed to change is a single line in Python code. And so, I mean, that's pretty nice. Like, it's pretty low-hanging fruit. It's just a single line. Oh, it's done. Work done. I have an incredible system. But of course, devil's in the details, right? But this exercise that I'm talking about is actually the main focus of something called MTEB. So what you just looked at, these 32,000 passages, are from a data set called the Cure v1 data set, which is open on Hugging Face. This work is from a project called MTB, Massive Text Embedding Benchmark. And that's all they do. They compare embeddings in terms of different languages, Italian, English, Polish. They look at different domains, like the medical domain, the code domain. They look at different tasks, like retrieval, clustering. And their goal is just to compare all of these embedding models to all of these different tasks to tell you which one is best for you to use. And the best thing is, most of this is all open source. And so here you see like the old model that we're using and the new model that I just changed a line of code and my 300% increase on performance. Of course, again, nothing comes for free, right? Embeddings are really important. So for me, it's almost like, why wouldn't you take this free kind of performance boost? But on another side, of course, the embedding model that I mentioned has like 4 times the size or more than 10 times the size of the original one. So there's infrastructure involved. There's latency involved. There's a couple of things that you need to take into consideration. Now, if you don't care about any of those, then just change your single line of code and you'll do great. Cool. Let's talk about structured outputs. So structured outputs is a door that I've been banging on for a while. For me, structured outputs is really what brings sanity to large language model enabled applications. So to give you an example, I take a user info base model, a Pydantic base model. I do this thing called, I basically create my client, and I do an API call to GPT 3.5 Turbo. God, this slide is old. And then I do the response model user info, and I tell it John Doe is 30 years old. And then I can do, on the response, it actually gives me back a Pydantic model. So I can say userinfo.name, and it will give me John Doe. And I can do userinfo.age, and it gives me the age. This is, for me, what finally brings sanity to the large language model apps. This is the way that we can integrate our large language model applications with the rest of the world. In fact, this is MCP. The Model Context Protocol is using this tool calling mechanism under the hood. For me, MCP is nothing more than 34 Pydantic-based models in a single file hosted in a fast API. That's it, because effectively, that is what it is. It's just using this tool calling mechanism that models nowadays are trained to do and give you back this nice little response. And for me, it's great. I really like it. Cool. But why do we need this? Because users, including me, hopefully you as well, we have trust issues with large language models. And a great thing to deal with this, and a great way to solve this, is to make verification easy. What do I mean by this? Let's create a fact-based model. My fact-based model has a fact, which is a string, and has a substring quote. My question answer is also a base model, that is, has the question, a string, and it has a list of facts. Now, a fact is that effectively something that is mentioned by the large language model, but needs to exist on the original context. So I'm enforcing that whatever fact the large language model tells me needs to be a substring that exists in the text. If this sounds weird, this effectively is what it does. If I ask it, what does Duarte do? And I give it a context. My name is Duarte, I'm a Portuguese technologist, whatever, yada, yada. And I ask a question. It will give me two answers using this kind of structured outputs. The first answer is, Duarte is a Portuguese technologist living in Copenhagen. But I know for a fact now that that substring, it comes directly from the context. So this is a way of us avoiding that the large language model kind of hallucinates. It's a way of us verifying that whatever the large language model said is effectively in the context. Of course, it doesn't solve the problem of hallucinations and things like that, but at least gives us a little bit more confidence, and most of all, our users more confidence, than whatever the large language model is saying exists, in fact, in the context. And users love this, effectively. It makes their life really easy because they stop mistrusting everything that is happening. And now, structured outputs are nice for answer verification and for bringing sanity to large language model-based apps, but all questions are not the same, right? Like some questions that the user asks will require API calls. Others will require different prompts, different escalations. Some of them will require human in the loop, and someone asks some weird thing, and we want a human to come in. And structured outputs also provide to us a way of dealing with these things. So let's say we have some user input, and then we don't know if it's going to be to a vector database, to a text-to-SQL system, or to a REST API call, or we have some sort of other user input that, depending on what they say, if they start insulting my application, I might send them somewhere or somewhere else. If we can effectively use this same base model strategy to define a question and a query type. And now a query type is an enum that effectively tells us where to route our query towards. So if the user's question, so effectively we take the user's question, we send them to a small LLM, but that is capable of structured outputs. And then depending on what they say, we can route that answer accordingly to where we want. It's especially nice if you use something really small and capable, because, hey, we don't need to solve AGI for query routing. It's a pretty simple task, right? And this is a nice graph from a nice book I read called The LLM Engineer's Playbook. I advise that book. It's really nice. Cool. Now let's talk a little bit about exploiting context and summaries. Now, there was a little bit of a weird thing on Twitter where someone took a database of tweets or blue sky skeets, and everyone was really mad because it was a bunch of user data. So I made an exercise, and I took a database of not 1 million, but 2 million blue sky skeets, which are the equivalent for tweets. And now I'm using polars to basically just give me the data set from Hugging Face. I really love this pollers kind of feature. We just like, give me the Hugging Face data set. And I collect those 2 million tweets. Now, let's say we have 2 questions we want to ask about this data set. My first question is, the user asks, what are the main trends in these 2 million Blue Sky tweets? The other question is, what are people saying about Bologna? Now, these questions are a little bit different, and we should effectively probably treat them in a different way. Like, if someone asks me about Bologna, then I go here to my keyword filter. Like, you're being very specific. It's like, how's the weather in Lisbon? Or why are people leaving Blue Sky? We want to give the LLM the specific context about Bologna of what is happening. And so RAG is great for this, right? Like a keyword search would be great for this. I want to focus on the things that are very specific for the LLM. Now, if I ask something like, summarize this data set, what are the main trends? Then we want to give the LLM like a general feel of what's going on in our data set. We don't want to match something specific. We want to give it like an idea of what my data set is. And the question is like, how the hell do we do this? Because we can't just shove our 2 million database tweets in the context of an LLM, even though those are getting really big. And so the first thing that we can do is just detect if it's like a representative filter question or a keyword filtered question. And this is the alternative of not using structured outputs. This is a very disgusting prompt with some examples of telling you, hey, if someone asks summarize the data, that's representative. If someone asks me about like, describe the negative, neutral, and positive perception of physicians, then I want something keyword-based. It's just a way of routing, which is much worse than using structured outputs. This is like me telling you why you should use structured outputs. Now, effectively, if the user asks me, give me a summary of the data set, and we do the traditional kind of RAG workflow, we'll effectively match all of the red sentences that are about summaries of data sets, because that's what you will match. And we don't want that, right? We don't want to get into the context of tweets about summaries of data sets, right? What we want is when a user asks me, give me a summary of the data set, we effectively ask, we want a little bit of each one of these different topic clusters. We want to get a little bit from there, a little bit from there, and a little bit from there. Now, who can guess what is the nice thing that gives me a little bit from everywhere? A little bit from everywhere is something that I've put on almost every slide. It's a library that I've put in almost every slide that I've presented. And we all go back eventually to scikit, which is one of my favorite libraries of all time. And we effectively just use for this k-means. We take our k-means class. We have our embeddings. We can fit k-means. We can say, hey, I want like 5 clusters. And then for each of these 5 different clusters, we'll take some items from each of these clusters. And what will result is that the context that I'm giving the LLM now is much more like, here's the feel of the data set. Of course, there's many ways to improve this. This is not perfect by any means, but it gives that nice kind of, here's a little bit of the data set, which in my case kind of solved my bottom a couple of times. Cool. Now we talked a little bit about exploding context and summaries. Let's talk about your beautifully ugly production data, which is one of my favorites. Because when we're preparing like our RAG systems, right, we're all excited. We're like, yeah, example questions from users. Is treatment of class 2 malocclusion recommended during childhood? Or what is the predictability of upper molar distalization with clear aligners? Like, it's very like beautiful questions, really well formulated. When then we go to production, what happens effectively is, instead of is treatment of class 2 malocclusion recommended during childhood, people say treatment malocclusion childhood okay? Or what is the predictable, distalization predictable upper molar? Like, this is how I Google. I don't know about you guys, but I try to write the minimum number of words to the thing, understand what I'm saying. It's like, I'm not going to write like question marks and things like that. And I do the same thing for all these LLMs. And then so this is effectively, we're going into the field of query understanding, which is the process of understanding what the user exactly means. And LLMs are also great at this. So I can use effectively an LLM to take the original search, PyCon Italy location 2025. That's a little bit more how I would Google for something. What effectively the LLM can do is take that single query, transform that into 5 different queries that are a little bit more understandable. And then for each one of these queries, we conduct like a top case search. And then we effectively can combine all of these results and then select the ones that we care about the most. So it's a way of kind of diffusing and decrypting whatever the user question was, and then match that context. Now, the way you select then these combinations is totally up to you. There's re-rankers, there's vibes, there's just send to LLM, select them for me. There's a couple of ways of doing it. And so we can use LLMs to not only derive the metadata from the query, we can look at their query and create a plan of queries from a single query. We can pre-process the query, and we can also use it to re-rank things, which is a really nice way. So we can use these LLMs to kind of as a pre-processing engine for our questions. Now to the core part. Is your system actually any good? And I was coming to PyCon Italy from Portugal, actually. And I got on a plane with someone called Rodrigo. He's also presenting. He's a really popular guy in the community. And he asked me, okay, we were talking about what we do and what I do and what he does. And he's like, oh, Duarte, cool, but like, how do you get clients? And I told him, the best way to get clients is to have clients. And he looked at me like, that doesn't mean anything. But it's true because, in fact, this also applies here. Like, the best way to evaluate your system is to get users. And this sounds horrible for a programmer. And we love this, right? We love using these RAG evaluation framework, like here's data set, context precision, faithfulness, answer relevancy. We love seeing these numbers go up, right? Like number go up, even though we have no clue what the number really means. It's like, yeah, like our context precision is 0.8, cool. So how I normally do how I tackle things is I would say like, I start with BM25. I don't even go embeddings route. I say like, here's my corpus of texts. Here's keyword search called embedding 25. It's pretty fast and it's mostly okay. And I just say, here's my like retriever. Fun fact, I had a production system just like this for about 8 months in production, and everyone thought I was using like advanced like embedding search. I was using BM25. And when we compared BM25 with embedding search, guess what? BM25 was always better because it was incredibly keyword searchy and all the users were just like writing Googles like me. So it was great. And it was pretty much free. First tip, start simple. Second step, log everything. Here's Loguru. I log the query, I log the context, I log the precision, I log the responses, I log everything. And so now I have something in place. Now I'm logging something. It's time to improve it. I can see what's going on. I can look at my data. I can analyze different examples. Are they any good? And now we start getting into, is the context relevant? Now we start thinking about precision. But you don't start thinking about precision before you put something out there. And I did a very weak attempt at the framework of like how to think about this, which is use your model or prompts to generate inferences or your retrieval system to generate inferences. Then you monitor and collect them. Then you extract the interesting cases where you failed tremendously. You review your data set and optimize the model or the RAG system. You create a new version of your service. You collect and you restart all over again. And you go into this flywheel. You just look at what's going wrong, increment, make it better, and go all over again. And I'm not talking about context and precision. I'm telling you about looking at your data and realizing where you failed. Cool. Final thoughts and resources. I got 1 minute left. It's just search. We start and it's just search. We talk about re-ranking, fine-tuned embeddings, faithfulness, relevancy, multi-hop querying. But in the end of the day, for me, it's just good search. It's just about giving your large language model what it needs, when it needs it, and using all the tools you can at your disposal. No need to get super complicated. Some concepts. Closing the loop early and starting really, really simple. Getting something out there. Log the most important metrics and decisions. Be close to product. I feel like people are scared of production. Don't be scared to understand what's going on in production. Note down your issues and improve them, and then repeat. Here's some resources for you. If you're interested in this topic, I've put them all in a tiny URL. If you're interested, you need to photo them. I think RAG resources, tiny URL. And that's it. Thank you very much, guys. Thank you, PyCon.
So, thank you very much for your talk. We have some question on Slido from the audience. So, first, what about facts that are not easily validated by your documents? So, for instance, there are questions implying complex reasoning by the RAG system. Is it possible to include reasoning in RAG systems?
Is it possible to include reasoning in your RAG system? It is. I actually do it quite often. What I actually do lots of times is that when I have something like this, question answer, I will very often do, my base model will be question, answer, and reasoning. And then the LLM will give me the question, like the answers, and will also give me the reasoning of why it reached this question. Even better. The reasoning here, instead of a string, can be a list of strings. So you can say, give me your steps for reasoning to answer this specific question. Yeah, it's a little bit of a hack. Like some people say that like structured outputs kind of affect the quality of LLM outputs, but I don't care because they work really well.
So, do you run automated tests on the bad examples you find in prod? How do you keep the tests up to date when your prompt and system changes?
Yeah, it's also a good question. Great question. So I brought this sad excuse for a framework. I was talking with my friend Luca yesterday about this. There's kind of two types of tests that I see, right? There's things that I want to have in CI that never fail or like fail to a certain percentage. Those are kind of the golden things, the golden behavior items. And those ones I keep in CI. But when I'm iterating on my system, I like to have this kind of notion of like a golden data set, like a data set of the default behaviors I like my system to have. And those are the ones that I will add on with the edge cases that I will kind of test on my notebooks and ensuring they are good. So I don't really like putting my golden data set of me experimenting in CI. For me, it's more like an iterative, where are things failing, where can I improve them type of thing. I don't know if I answered the question directly, but yeah, those are some sentences about it.
Okay. Now a suggestion. What is, in your opinion, the best framework or project to start building RAG systems?
None. No, effectively, like, of course, some of these lang graphs and lang chains are really good for you to get a prototype out there. But eventually, like, you will need to know what's going on. And so I don't start with the code, first of all. I start with like how I see the system. And then, of course, you can jump to these frameworks, but a lot of these frameworks will be doing some like Kung Fu Ninja on your prompts that you don't really know what's going on. So I'm a big advocate of also like getting your hands dirty and knowing what's going on. And so don't start with the framework. Like if your question is what is the framework, you're starting the solution with the technology. And for me, you start the solution with the solution, and then the technology comes along and is whatever is best for you. But I don't recommend frameworks.
Sure. And first, you showed up on the slides some Pydantic.
Yeah.
And somebody asked about, have you ever messed with Pydantic AI?
I have. It's a great framework, but I don't use Pydantic AI. I think it's a great framework, but I've tested it a couple of times. It's nice, integrates well with Pydantic. I really like plain Pydantic because, as like I showed you, it's nice that we have like the base models, but you can also like do all types of like methods on these models to like validate SQL for text to SQL or do a lot of crazy things. So like default Pydantic is really nice as well.
Okay, so thank you very much. For other questions, you can reach him.
Thank you very much. Thank you guys.